Okay, hello everyone, good morning. Today we start talking about machine learning and deep learning and other concepts of artificial intelligence using Spark environment, but our programming language is Python. So basically, today material, especially the first half of it, are gathered from one of my friends at Aube University, Dr. Ross Gutzelmacher. So anyway, for your final project, you need to do it like data mining projects similar to what you already did in data analytics programming and also visual analytics. But you need to learn or change your coding approach to be able to do something on a Spark environment. So also this course, I expect more from your final project because in data analytics programming, I expect that you just start to learn Python now. You need to do more sophisticated, more complex project. So I think one of your friends had a question, right? Hello? Okay. Oh, I was thinking I heard the question. But you can do in groups of 2. And the due date is the last week of the class. You can either present in the class if you come in person, or if you don't, or if you want, even you can come in the class, but then you can make a video and just send me your video presentation, PowerPoint, notebook, data, whatever, and I should be able to run your code. So these are the elements that I expect from your final project.
Like, do we have to keep do we have to use like Hadoop and HDFS Spark, these technologies, or like using a Python, just a Python, maybe on
yeah, I mean, even if you submit a Jupyter notebook, but the Jupyter notebook, you should run it over a big data infrastructure that, for example, I run one of them today. So basically, you can do it over Amazon AWS or over even on your system. But for being used, even if you do a Spark, PySpark, the way that you code is different from ordinary Python code. And you can do at most groups of 2 students, or you can do by yourself. Just one group of 1 student is enough too. So either 1 or 2. Any other questions? Okay. So again, let's review some general machine learning and basically artificial intelligence concepts. I just review for today, but for next 2 weeks, I recommend to go back to your programming analytics course and review some Python programming, because I don't evaluate you for your Python knowledge, but I expect that you'll be able to run some Python codes and do analysis. As you might know, there is no general definition for machine learning, data mining, data science, artificial intelligence. Sometimes they overlap, but let me just read to some general description or definition of them. Machine learning, artificial intelligence that learns predictive models from data. Deep learning, which is one of the most recent topics that is still very hot. We also review that, but let me just go next slide. Machine learning term is coined in 1959 by Arthur Samuel. He defined machine learning as a field of study that gives computers ability to learn without being explicitly programmed. So Tom Mitchell in 1998 had a more precise definition. A computer program is said to learn from experience E with respect to some task T and some performance measure P if its performance on T as measured by P improves with experience E. Anyway, I mean, it's a little complicated definition, but at the end, you need to use some algorithms to get some insights from your data. You might remember in the data, analytics programming course, we have two types of insights from data, and it depends on the application. For example, in the healthcare, let's say you want to see which factors associated to someone's blood pressure. You might use some data and then see that maybe somebody's weight, age, maybe type of medicine that they take are associated to blood pressure. So although you predict, but prediction of blood pressure is not very important. It's still important, but the more important is the factors associated to your outcome. In some applications, like predicting the stock price in the next day, your focus is on more accuracy of your prediction outcomes. Although important variables are still you take them, but the most important thing is predicting the actual price in the next day. We have three types of machine learning algorithms: supervised, unsupervised, and reinforcement learning. For this class, our focus on supervised and unsupervised learning. If you do reinforcement learning, I give you a bonus because it's much more challenging and it's out of content, but you're more than welcome to do that, and I take it into account. So in supervised learning, we have a labeled data that we try to predict. It could either be a price, which is a continuous label, or it could be a classification problem, which your dependent variable could be in different categories. Let's say for healthcare, we want to predict if somebody can survive after 5 years of a transplanted surgery or not. They either die or survive, so dependent variable has two categories. In unsupervised, we don't have any labeled data, but we try to categorize our observations based on their similarity. For example, you want to do a marketing campaign on a population. So maybe type of products that younger generation, women or men are different. So for each type of your observations, you need to run certain marketing campaigns. So it's important for you to be able to categorize your observation similar groups. And the last one is reinforcement learning. It's actually the most natural ways of learning. It's like a little baby, and they give them hot peppers, candy, and let's say just these two. And the baby doesn't know which one is good and bad. He just tried the first one. Candy, it gets some prizes. It tried the hot pepper. The baby doesn't get a prize. It's annoying. So next time, if you give both of them to a baby, the baby already learned from the previous experiment and picked the candy. So basic reinforcement learning is based on rewards, and also is, in my point of view, is most natural way of learning. These are the general algorithms. We know that our dependent variable is either continuous or categorical, and we have two types: unsupervised and supervised learning. So these are some examples. For example, unsupervised continuous, we can talk about K-means, the most famous one, PCA. Supervised continuous linear regression, which is the most common, and probably doesn't matter which measures you follow. Regression is the very famous. Random forest decision trees. And for unsupervised categorical, like one of the most famous one, FP growth or hidden Markov models. And the last one, supervised and categorical, KNN, decision trees, logistic regression, and so on and so forth. Any questions so far? So if you're over Zoom, you can either use your microphone or just chat with me. Okay, this is the simplification of types of machine learning algorithms. So at the end, most likely you had either classification, regression, or clustering. So here you see two visualization of supervised and unsupervised learning, and we just have two inputs. So and since we have x1 and x2 as our independent variable, we can visualize it. If we have more than two variables, 3, 4, it just gets harder and harder. On the left side, you have either a blue circle or red cross, and using algorithm, you can just find a border that classify them in two groups. In the right side, we don't have any labels. All of them are blue circles. We just classify them based on their closeness. So the circles are closer to each other would be encircled in the groups. In the regression, we try to find a model, and basically in the like 2 dimension, it represents a line, and the differences from predicted line to the actual observations accounts for error. And based on the internal algorithms of regression, we try to make a line that minimizes the overall error from all the observations. This is representation of logistic regression. Basically, your label is just 0 or 1 or yes or no, basically just two categories. And using the formula, we try to find our prediction to belong to either 1 or group 0. Neural network. So neural network basically you have some numerics as your input layer. You transfer them to the hidden layer. So for example, let's say in this circle I have the number of 5, and on this line I have like coefficient of 2. 5 times 2, 10. So and maybe 2 from this come here, 12, maybe 5 from here, 17. So this middle circle would be 17. And same for the others. At the end, you want to predict your label. So there is some internal algorithms that try to find the coefficient of each line, which we don't go in that much depth. And that's just neural network. It's a black box model, and based on some internal algorithms, it tries to find the coefficients of each line. So let's look at the sample neural network algorithm presentation. Sorry. So I just copy and paste the link. So this is just a presentation. We have x1 and x2, two input variables, and on the features, I can either have x1, x2, their square root, their multiplication, and their sinus. I just go up to this point. For here in the hidden layer, you can identify how many elements you want. Let's say make it 5, and I just have 2 outputs. Train and test. Here I just say, let's say 70% train, and as you see, when I increase noises, the points are more mixed to each other. So it makes the problem more difficult. Let's just do this up to here, maybe 20 noises. That says 10.
The Zoom didn't show your screen.
Oh, it doesn't?
Yeah.
Okay, thanks for letting me know. Can you see this?
Yes.
Okay. On the left side, you identify your input layer features. It's either could be, first off, you have two independent variables, x1, x2. It could be their just x1, x2, their square root, multiplication, their sinus. I just select these 4. Number of hidden layer, you can just make it 3, 4, 5, 6, whatever. And you have 2 neurons in the output layer. And in the right side, you see your observations that you want to classify them or categorize them in 2 groups. Sorry. So for input, you can, when I go under data, as you see, it could be a circle, this kind of problem, this one, or this one. Here you identify your train and test. And if I increase the noise, as you see, the data points mix more to each other. So I just make this one. So it just you play with the hidden layers, input and output, then you run. First, it identifies two groups. As you see, there is some errors. Some blues are in the orange side, and some orange are in the blue sides. Now, as you see, the meter is running, so it just, through the time, it tried to improve the categorization problem. So it takes a bit of time. We just let it run. Later we see if there is an improvement in clustering or not. There's either classification, blue or orange. Yeah, this is just a visualization. This is just a sample. So let's see what happens.
Professor, can I have a question?
Sure.
So when I increase the number of noise in this website, the Tesla loss actually decreased. Why does that happen?
What
increase sometimes like when I increase the noise, the test loss actually decreased, and training loss.
When you increase noise, you say what increase?
When I increase the noise, the testing and training.
Okay.
The testing loss and training loss decreased. Then I increased the gain, the testing and training loss increased again. So why does that happen? Is that a random thing?
Actually, it's running. I don't want to stop it, so let me just run another one. Okay, so here you said when you increase noise, what happens?
Testing test loss decreased.
Test loss? There's a test, train and test here. Does it change?
Yeah, no, it's the output there.
The output on the right side, right?
Yeah, it decreased.
So as you see, when I increase the noise, they are more mixed to each other. It just makes the problem more difficult. When I decrease the noise, they are pretty separate. So it's the only thing that changes. I'm not sure if I could answer your question, by the way. So
yeah, that helps.
So when you play with the noise, you just make the problem more difficult, because now it's more mixed to each other, so it's much harder for your algorithm to classify them correctly. As you see our case here, still we have some error. Do you see this orange dot? It's in the blue side. It shouldn't. So it's classified as a blue. And these two blues are in the orange side. So now it's running and try to improve the prediction. Okay, but it's just an example. I mean, they just made a visualization for you guys. Another famous algorithm is support vector machine. So as a two-dimensional example, you have some black and white circles. It just try to find a border between these two lines to classify them correctly. Another one is k-means that you use for clustering. So as you see, we have three clusters of red, yellow, and white. It just tries to find the border that categorizes them correctly. But what is deep learning? Basically, deep learning is not too much different from a casual neural network. You just have more than one hidden layers. So if you're in your neural network, you have more hidden layers. Two things happens. Basically, the most important is more computational, because the internal algorithm should work much harder to identify the coefficients of each line. Another one, you might improve the prediction, but it's not always the case. Deep learning usually for visual analytics, image processing, and even, pardon me? Yeah, this could be kind of visual prediction. So basically your input data is a visual file. It could be a video, a picture, handwriting, those kind of things. So what happens, basically, you need to convert a picture or video or text to a numerical value. So on top of a neural network, you should add a step to convert a picture to a numerical equivalence, then use it as an input for your deep neural network. So on top of extra internal calculations for finding coefficient of lines, you have an extra step for converting a visual file to a numerical equivalent. Like here, the different sections of pictures are taken. In each hidden layer, they just take care of one part of the picture. But it's not the way that hidden layers just get, for example, here, they don't focus on the eye. They just get a numerical equivalent. But in each hidden layer, you just focus on a certain part of the picture. For example, in the first one, you focus on the edges. In the second part, corners and contours. In the third hidden layer, you focus on the object parts. And in the last layer, you do the prediction. Yes?
You don't have to know exactly the function of each layer.
Basically, there is some, you can do some tuning by yourself too. For example, at the end, your outcome is a probabilistic outcome. It comes from activation function. So you can, and there is different types of activation functions that you can say, use this one or use this one. See which one brings a better accuracy. But the point that on top of adding more layers, even you can work the number of layers, maybe you just increase them. Also, you need to know how to convert a picture to a numerical equivalent for your neural network. So two things happen. First of all, adding more layers, and second, how to convert, which basically you just use a package. So use a package to convert the picture to numerical equivalents. There is two famous types of deep neural network. One of them convolutional neural network, or CNN. The latter one is recurrent neural network. So CNN is mostly for image classification. RN is mostly for language processing and sequential data. Again, in some, if based on your project, maybe deep neural network doesn't work. In my dissertation, I just used logistic regression, and it had the best accuracy. So it depends on which type of data you have. It doesn't guarantee that if you use RNN, you have the best performance. You need to just try to see what happens. Usually in visual analytics and visual processing or image processing, for example, CNN has the best performance. So I don't go that much in details. Okay, let's see what happened to our example. Still working. As you see, something in the middle turned out to orange. At first, all of them were blue. So I just try to improve the prediction. Maybe we should wait like half an hour or more, see what happens. But so far, as you see, even in this algorithm, which comes from TensorFlow, this application comes from TensorFlow, there is still some errors. By the way, TensorFlow is the most common technology or platform that you run your neural network. either in R or Python, you connect to TensorFlow and just input your data, get some outcomes. But it's one of the most common. Pardon me? Torch. That's another one. Torch, stencil.
Why, I have an internship in the summer, so the company just really use the approach.
So maybe you can do your project on PyTorch. You don't have to do TensorFlow. It just depends on. I know that some of them work better with some certain hardwares. For example, GPUs. So sometimes they run over GPUs. Maybe in that company they have better outcome with PyTorch. But at the end, doesn't matter actually. I mean, they might say maybe today they make a new platform XXX. You just need to import that to get your outcomes. So again, the general application of convolutional neural networks are image processing, video processing, image captioning, and natural language processing. Recurrent one is mostly for sequential data, even natural language processing, time series. These are the most application of the RNNs. These are the most common RNNs algorithms: recursive neural networks, RNN, gated recurrent units, GRUs, and long short-term memories, LSTMs. All of them, usually in time series LSTMs works really good, but at the end, you shouldn't worry. Maybe they ask you to do prediction using logistic regression or LSTM or RNN. At the end, you just need to know how to change the format of your input data to something that works for logistic or RNN or CNN. So no worries about the very fancy names. The only thing that you need to know how to convert your input data for those algorithms. Okay, so our focus from now is mostly machine learning over PySpark environment. There is very good guidelines that you can follow. Let me just copy this link and go to the website. Okay, as you see, now we have less errors. Some of the blues that used to be in orange, now they are in the blue side. So after a while, we have some more improvements here, but let's go to this link. So as you see on the left side, we have two sections. First is MLlib, and the second one is, the first one is mostly data frame, which is you're probably more used to that. So your input data is through the data frame. You have rows and columns. The second one, you see some tutorial for RDDs, which in the last class, you have example, for example, one text file. We divided, we imported line by line, and each line represents an RDD. There is some rumors that RDD would be obsolete, and people, there would be more development over data frame based data entry, but it depends. Maybe you go somewhere and do internship and they still work with RDDs, but there's not a big issue. You still can work with RDDs, but it's more convenient for me, at least for me, it's more convenient to work with the data frame. It's more intuitive. And just look at here. For example, on the basic statistics, you see a Scala, Java, Python example. They teach you how to do that, give you a sample code, like pipelines. You might remember we talked last class, classification and regression. So even you can find very good resources here for your project. As you see, if you are very good in R, there's some R example too. So you can have RSpark, PySpark, Java, and Scala, run all of them over the Spark platform. For example, you click on Py, and you see how they, here, for example, in this example, they try to do logistic regression in PySpark, and they teach you how to import your data, just doing classification. Even they teach you the mathematics behind of that is very interesting, and really good resources. So with this link, you can get some very good examples, sample codes for your final project. So I recommend just go through them one by one. So any questions so far? Okay. So let's go to the last part. How to basically run your project, or for example, Shashank asked, I mean, do you want to run your PC or some cloud? Hopefully we have time to cover all of them. So the most famous one is Amazon AWS, but there's a recent platform, Databricks, that was built over Amazon AWS and just makes your life much more easier. So Databricks was founded by the creator of Spark, and there is much less headache than the others. So you can start working with Databricks, and you can start doing that. It's not really difficult. You can do over VirtualBox and local installation, but it's more difficult, but there's a good learning for you because you learn how to something related to hardwares and the back, you get a little bit understanding of the under the hood. So, but I don't care, and then you can just use any of them and any of those platforms and run your project. So today we try to do with the Databricks. Just here. Huh? Yeah. So in Amazon AWS, which hopefully we have time next class or next week, you can apply for a student credit, which used to be $100. I'm not sure what's happened, but there is some issues that I tell you, but usually students get overcharged, and you should plea for reimbursement, and they forgive you. But I mean, usually, it's based on my experience. Usually, students get like, one of my friends got charged like $1,100, but they forgave him. So just on that, copy and paste the link. Put your information here, and just sign it up. So since I already signed up, I cannot do it again. But basically, just first name, last name, email, and here you can say you want it for education. And when you sign up, you get a link in your email address. Let me show it to you. And then click on this link. And then just select the community version. So when you click on this link, there's two sections. On the left side, there's a paid version. On the right side, there's a free community version. Select that. So I give you 5 minutes to go to all of them. The community, the right one. Just remember, select the community edition. And if everything is right, you should see such a page. So I still give you 2 or 3 more minutes. Okay, the next step is just be sure that you already downloaded the movie lens dataset. So you want to enter the movie lens dataset to this Databricks environment. If you already installed, that's fine. I mean, if you already downloaded the movie lens dataset, that's good. But if you didn't, please go to the movie lens website and download the ML100K file and unzip. Shashan, could you send it to group me? Yeah. Okay, so let me just. So, okay, this is what Shashan did. So just on the right side, click on the under Community Edition, click on Get Started. So if you do everything right, you should see, what is that? This page. Still, I give you 1 or 2 minutes. So. You shouldn't see this one. Yeah, you won't see this under recent. You won't see this first because I created in the previous class. So. So, but how Hadoop or Spark works? First, you need to run a cluster which has computing node. On top of the cluster, your Yarn and Hadoop, basically the Hadoop code, which includes Hadoop file system and Yarn should be running. And on top of Yarn, the Spark environment should run. So first, we need to run our cluster. So either in any ways, Amazon AWS or your local system, you should do same. First, you need to run the cluster. So for this, go to cluster, create a cluster here. So just click on create cluster. Just put a name. I just put sample as a name. And just let the rest be as a default. So for example, default is runtime is Scala and Spark 3. And just hit create cluster. Next to the sample, you see there's something is, what happened? Okay. So next to sample, there's, you see it's loading. It might take 5 minutes. So let's just wait for that. Again, if you click on cluster again on the left side, you see it's still loading. We cannot do anything else. We should wait for the cluster to be loaded completely. The next step, you should import the movie lens data into the cluster. The third step, run a Spark over the cluster and just put your Python code inside that. It might take 3 to 5 minutes, so let's just wait for that. As you see, next to my sample, there is a green dot. It just means my cluster name, or sorry, my cluster, the name of sample is running. So now the status is running. And also, I have one note here. So next step, we need to import the movie lens data into our cluster. So on top of cluster icon, there's a data icon. Click on data, then click on add data. Here you see there's a browse part. Click on it and find u.data from your local system. It's a 2 megabyte files. If you could load it successfully, you see the red sign, sorry, green sign here. Just to wait for your friends over Zoom to do that. So after loading the u.data into the dataset, click on Create Table with UI. It's just asking you the cluster. So we already created a cluster. Click on it. So here you choose your cluster name, then click on Preview Table. And down here, you preview. You see your data. You can put an arbitrary name here, just change it. For example, my name is u_2_data because in previous class it was u_1_data. Now it's 2. For you, it's probably u_1 data. So I wait this one to be loaded. As you see, it has some internal algorithm to just guess the type of column. As you see, all of them are string because user ID, movie first column, you can change it to user ID. Second one, movie ID, or you can use the default name, that's fine. The last one, the rate. All of them are string, but you can consider it as an integer too, because it makes sense to make average of them. You can leave it as it is, or later inside the Python change the column type. So no worries if you forget to change to find the proper name. Let's say just for this one I put integer, and the last one I know is the date, but in the computer format, so I just put time stamp. That's it. Now my table is, I create the table. Click on that. I got an error. I'm not sure what happened, but it's okay. It's already inside my, I already imported the table. So if you click on data, let's see, it should be somewhere. Okay, on the data, I click on sample, tables. Your class is not lucky. I'm not sure what kind of error I get. Let me just, yeah, the data is already imported. So now on data, I see all of the tables that. So if after importing, just click on data, and you see all of the tables that you could import it. So what we did so far, we run a cluster on top of using the cluster. We imported the data. Now you can use something like Jupyter Notebook to run your Python codes. For that, click on Databricks here icon, and then create a blank notebook. Just you can say sample code, any arbitrary name, and default language Python, or SQL or whatever you can. And we just have one cluster, which is sample. So we using the cluster, we load the code, and we load the data and also run our code. Then I click on create. And as you see now, I have something similar to Jupyter Notebook. For example, 1 plus 1, then you press Shift and Enter together, similar to Jupyter Notebook. Shift Enter, 2. Now let's do something with our data that we just imported. So I put the sample code in your last slide. For example, as you see in the first one, we import the Spark package, copy, paste here, Shift Enter. Now I import this package. Next, I import the data. So my data name is u_data. But for you, it could be different name. So u_data is arbitrary name. Using SQL context.sql, I said select star means select all of the rows from this table that we already imported. So Shift Enter. I assign that imported table to a variable of data. Now, the rest is similar to Python. For example, do you remember how to show the table in your Jupyter Notebook? How to? Okay, do you remember? Huh? There are different ways. One of the easiest one that I like, data.show. This class, this method. So there's so many other ways to show. So as you see, I have user ID, move ID, because I changed the column name, rate, and timestamp. And the remaining are like similar Python. You can do use logistic regression, classification, so on and so forth, which we talk later in your next classes. As similar to your final project, you should be able to import to your PySpark environment and just run your machine learning algorithms and report a complete project. Your due date is the last week of the class, and I give you further details. It's similar to your data analytics project. You need to have some basically introductions, literature review, analytics part. I need to see your Jupyter Notebook. You should submit your Jupyter Notebooks, your writings, your calculations, and your data, and I should be able to run your code. So please check for error. So if I cannot run it, I couldn't be sure that I'm fair for everyone. So I should be able to run your code. And you should also report good insights. You should, not only you just able to run the code, you should get some good results and say what you see from the data, what kind of contribution you could have. Again, this environment is for running very large data sets. So, but for your class project, you can do very large data set, but usually for a small data set, you don't, using Hadoop environment is not very efficient. Even it might be slower. But it's just very efficient for very large data set that you cannot run with, simple, complicated system or fancy systems. Okay, that's for today. Any questions? So if there is no question, one of the points that later, hopefully we have time to go over Amazon AWS, you need to shut down or terminate your cluster. Especially in Amazon, they charge you too much if you forget to terminate it. So just go over your cluster. You just have one cluster here. Click on this button, terminate this square, and just terminate it. It's very important in Amazon. Otherwise, if you leave it for 1 month, at the end of 1 month, you might be $2,000 charge for you. So, but usually they forgive, but I cannot guarantee that they forgive forever. Sometimes, I'm not sure. Hopefully they always forgive. Okay, that's all today. Thank you very much and have a great week. Let me just